Welcome to the second tutorial of MATLAB tutorial series by Anshu Pandey. My name is Anshu Pandey, and for any assistance and help you can write to me at anshu.india@outlook.com. Now, today's tutorial is on working with arrays and matrices. Since the screen over here shown from first tutorial is full of commands, now for clearing skill what we can do is we can write CLC. So it will clear out the screen, but all the variables in the workspace will be shown at the same time. For clearing variable, what we can do is clear all. All the variables you can see is cleared from the workspace. Now I'll start with vectors. Vectors are special cases of matrices in the sense that a matrix with only one row is called a row vector, and a matrix with only one column is called a column vector. Now how to define a row vector or column vector is, we can simply write, for example, A equals to, in square brackets, we can write different columns with space, 4 space, 5 space, 6 space, 3. Now this would result into something like this, a row vector. Instead of spaces, what we could have used is, we could have drawn commas over here. Commas will also result the same thing as the spaces. So it forms a row vector. Now in case we want to form a row vector, there is another method using colon operator. So what colon operator does is, colon operator starts from a particular number and goes with default increment of 1 to the ending number. For example, what we can do is A equals to 1 colon 8 would result into a matrix 1 2 3 4 5 6 7 8. Now this is a row matrix again. Now in case we want to form a column matrix, let's say B, then what we can do is, in square bracket itself we can put 1 separated by element separated by semicolon, semicolon 3, semicolon 5, semicolon 7, semicolon 8. Now this would result into a column vector. I hope you learnt about column vector and row vector. Now for creating a row vector, there is another function called Linspace. We can not call it a function, it's an instruction. Now what Linspace does is, it creates a vector with some elements linearly spaced between the specified initial and final values. For example, C equals to Linspace. We can specify the initial and final values, and at the end the number of variables we want into between them. For example, from 4 to 17 I want linearly spaced 8 variables. So what I can do is, it would result like this. Now similar to Linspace, there is another function called logspace. You can use that as well. Now I guess this is clear to you, all the vectors. Now coming back to matrices. What are matrices? Matrices are defined by entering the elements row by row. Thus in a matrix, each row of elements is separated by a semicolon, and every column is separated by space or comma. In case we want to define a matrix, how we can do is, for example, M equals to, in square brackets, what you can do is 8 space 7, 5 space 7, it would form 3 columns, and in second row what you can do is 7 space 2 space 6. Now this will result 2 cross 3 matrix with the 2 rows and 3 columns. Now these are the simple methods of forming a matrices. Now using colon operator also you can form a matrix like this. For row you can define, for first column you can define from 1 to 5, and for second column you can define from 2 to 6. Now this will result into matrix. In case in this colon operator you don't give a particular proper value, in that case elements in the second row exceeds from the elements in the first row, it would show an error. For example, like this: ket argument dimension are not consistent. It means the number of elements in any of the row are either less or greater than. Similar to this, there are also inbuilt instructions defined into MATLAB to form matrices. Like what? You can also use B equals to empty small brackets, and it will form a null matrix. Others, for example, V equals to zeros of, if you give here one attribute as an input, it would form a 3 cross 3 of zeros matrix. example, you want to look after V, it is something like this. And instead of that, if you form something, if you give two attributes 3, 5, then it would result a 3 row 5 column matrix of zeros only. Similar to this, there can be matrices of ones as well. Now you might be thinking, for forming a matrix of 8 you need to write 8s, but it's not like that. What you can do is, what we need to do is, there are only zeros and 1 defined into MATLAB. For forming a matrix of 8, 7, anything, you can do 8 multiplied by 1s of 4, 5, or either single attribute, any of the attribute you can give accordingly, and it will form a matrix of 8. Now similar to this, there are other function as well. S equals to rand function. Rand function forms a random matrix with elements valued between 0 to 1, and the size we can mention over here. For example, we want a square matrix, we can give 3 or any 4, any of the values. It will form a random matrix of that. If you give 2 values, it would result like this. Similar to rand, there is rand I function. Rand I function does, it goes to a maximum value greater than 1, like 8. 8 would be maximum value, and the size of matrix will be 3, 4, 3 rows 4 column. So here we are having matrices which are having elements which are having value greater than 1 and to the maximum value 8, I max. Now similar to this, if you want to form I matrix, you might have heard about it. I matrix, we can call it identity matrix. In identity matrix, we can form like I, and for example 4 attribute I give, sorry, this not be equal. Now it's correct. So 4 cross 4 I matrix we are having over here. Now similar to this, there are other functions also defined into MATLAB. For example, we want to form a magic matrix, so it would be something like this: magic of 3. Magic matrix form a square matrix in which the sum of elements in rows and columns are always equal. For example, here you can examine 8 plus 3 plus 4 15, 8 plus 1 8 plus 3 plus 4 15, 8 plus 1 plus 6 15, 1 plus 5 plus 9 15, 6 plus 7 plus 2 15. Everywhere it is 15. Anyhow, you check it out, right? And the next is one more, is like there are a lot of functions defined into MATLAB. For example, Pascal, we can form a Pascal matrix of 4 cross 4, something like that. It will result a Pascal triangle matrix. You can analyze it out over here. Now this was the part where we could have used matrix formation. Now let's look after matrix manipulation. Matrix manipulation means working on operations with matrices. Now let's say we have two matrices called A and another matrix called B. So A and B, we are having two matrices. Now for adding A and B, what we can do is C equals to A plus B. So it will result addition of two matrices. Similarly, we want to subtract matrix 1 from matrix 2. We can write C equals to A minus B. So D equals to A minus B. Similarly, we can write Z equals to A into B. So in multiplication, dimensions should be similar. For example, 2 cross 3, then other matrix would be 3 cross 2. Let's take another matrix. For example, T equals to 3 cross 2 matrix like this. If the number of columns in earlier matrix is 3, then number of rows in the next matrix should be 3. So we having T matrix. Let's look after it. T matrix is this. Now we can multiply D into T or something, C into T we can do. So let's do it. E equals to D into T. So it would now result in multiplication of D and T. In case we want to find the transpose of any of the matrix, what we can write is, for example, finding transpose of matrix D. So D dash D single semicolon will result into transpose of particular matrix. Now one more thing, while we do multiplication, in multiplication what happens is key elements are multiplied rows to column. In case we want to do the element to element multiplication between A and B, for example, let's look after A is this one and B is this one. Now in case we want to do element to element multiplication, we can use dot operator into MATLAB, which is defined A dot B. Now this will result into 7 7s are 49, 5 8s are 40 and 5 3s are 15, similar to other next row as well. So this will result into element to element multiplication. And in case we want to find the square of any matrix, let's find the square of matrix B. We can put like this. So it would, inputs must be scalar or a square matrix. Square of matrix can be found for us only square matrix. Now let's go to T matrix. We can find the square of matrix T. So it is something like this. Now in case we want find the square of element to element matrices, what we can do is T dot, this is element to element multiplication of particular matrix. Now in case we want to find the inverse of any matrix, we can write E and V. It's capital I wrote, it should be small. Yeah. So it would be infinite. It might be because of square matrix, it might be some errors over there. So this is how we can do matrix manipulation. I hope you like it. One more thing remaining is matrix concatenation. Now let's talk about that as well. Matrix A is this, matrix B is this. In case we want to form matrix C, which is combination of matrix A and B, what we can do is C equals to A space B. Now this will result into a matrix in which both are concatenated horizontally. If you want to concatenate them vertically, what we can do is A semicolon B would result in concatenation into vertical form. Thank you for watching this video and I hope you like it, and stay tuned for other videos as well. Thank you.